Hello and welcome to the solutions to our Surds homework video. We'll just be going through all 11 questions that were in the homework and hopefully clearing up any doubts that did occur along the way. So with question one, part one is simplify 3 root 2 plus 2 root 2. Hopefully you can see here we're just adding like terms together. So that's just going to be 5 root 2. Over here, we have root 32 minus root 18. Now, at first glance, it doesn't look like we have like terms, so we can't really add or subtract. But really what we need to do is simplify each surd. So root 32, we know we can write that as root 16 times root 2. And root 18, we can write as root 9 times root 2. That's going to simplify to be 4 root 2. And that's going to be simplified to 3 root 2. So 4 root 2 minus 3 root 2 is going to be simply root 2. So hopefully question 1 makes sense. With question 2, we just need to simplify the following. We've got 2 root 5 times 7 root 15. So with that one, all we're going to do is multiply the numbers together, so the rational parts, and then multiply the irrational parts together, and then go from there. So we've got 2 times 7, which is 14. And then we've got root 5 times root 15, which is going to be root 75. From here, we can simplify the root 75 into root 25 times root 3. And that's going to be 14 times 5 times root 3, which simplifies to be 70 root 3. Now, hopefully for the rest of the video, I'm not going to actually go through how to simplify root 75 into 5 root 3. I'm just going to assume that's all prior knowledge at this point. And if it's not, please check out our video on simplifying surds. So with question 2, we've got 4 root 3 times 2 root 6. That's going to be 8 root 18. And then we can further simplify that root 18 into 3 root 2. And so we end up with 24 root 2 as our final answer. With question 3, we need to expand and simplify the following. So with question 1, what we want to do is, just like normal expansion, distribute with the brackets. So we have 3 root 5 times 5. So that's going to be 15 root 5. And then we're going to be left with 3 root 5 times root 5, which is going to be 3 times root 5, which is just 5. So we're going to end up with 15 root 5 plus 15. With question 2, once again, just like normal expansion, we want to multiply everything, have those pairs. So 2 root 3 times 5 root 3, that's going to be 2 times 5, which is 10. And then root 3 times root 3, which is 3. So we times that by 3. The next pair I want to do is 4 times 5 root 3. So that's going to be 20 root 3. And then I want to do 2 root 3 times minus 1. So that's going to be minus 2 root 3. And then I want to do 4 times minus 1. So that's going to be minus 4. So 3 times 10 is 30. 30 minus 4 is 26. And then 20 root 3 minus 2 root 3 is going to be 18 root 3. And that is our final answer for question 2. Moving on to question 4, we want to simplify the following. So with these ones, I'm not going to go into the complete working out. I think that'll take way too long. But for now, I'll just put up the answers. So for this first one, root 1024 times root 2. We know that root 1024 is 32, and so it's going to be 32 root 2. Like I said, it's pretty hard to get 1024 as that first square number straight off the bat. Most people will divide that by 4, so they'll first do it as like root 4 times root 512, and then keep going on like that. And that's a perfectly fine way of doing it. This is just the solution, so I'm not going to go into all the nitty gritty. But like I said, do watch our video on that if there's a problem. Root 44 plus root 63 plus that. So the root 44 we can simplify into 2 root 11. The root 63 we can simplify into 3 root 7. And then the 2 root 275, we can simplify that into 5 root 11. So I'm just going to write that and then times that by 5. So then we've got 2 root 11 plus 3 root 7 plus 5 times 2, so 10 root 11. Collect the like terms, so we end up with 12 root 11 plus 3 root 7. Moving on with part 3, root 162, that's going to be 9 root 2. And then root 200 is going to be 10 root 2. And root 288 is going to be 12 root 2. Like I said, if you don't know why that's the case, check out our previous video. Now what we're going to do is they're all like terms. So 9 root 2 plus 10 root 2 is 19 root 2. 19 root 2 minus 12 root 2 is 7 root 2. So we end up with that. Question 5, rationalize the denominators. So with this one here, we've got 9 root 3. What we're going to do is multiply the top and bottom by root 3. Once again, if you don't know why, check out our previous videos. But it's going to be 9 root 3 times by root 3 over root 3. And so that's why I'm not changing the actual value of the fraction. So I end up with 9 root 3 over 3, and that simplifies to be 3 root 3. With question 2, I want to multiply by the conjugate. So I'm going to be multiplying by 2 minus 3 root 5. So multiply by 2 minus 3 root 5 to the bottom, and multiply by 2 minus 3 root 5 to the top. And that's going to get me 44 minus 66 root 5 over difference of squares on the bottom. So I'm going to get 4 minus 9 times 5, which is 45. So I end up with 44 minus 66 root 5 over minus 41. And finally, we have question 3, 5 over 2 minus root 3. What we're going to do is multiply by the conjugate. So the conjugate is 2 plus root 3. So multiply that to the top and multiply that to the bottom. And we're going to end up with 10 plus 5 root 3 on the top. And on the bottom, we're ending up with a difference of squares. So 2 squared is 4 minus root 3 squared, which is 3. So 4 minus 3 is 1. So our final answer for that one is simply 10 plus 5 root 3. So hopefully all those made sense. All right, so with question 6, we want to simplify these two questions. And for the first one, we want to be using our perfect square. So we know that a minus b all squared is going to be a squared plus b squared minus 2ab. So with this first one, we're going to square the first one. So it's going to be 2 root 5 all squared. So that's going to be 4 times 5. And then we're going to add on the root 3 squared. So that's going to be 3. And then we're going to minus 2 times ab. So a is 2 root 5 and b is our root 3. So that means we're going to get 20 plus 3 minus 4 root 15. And that means we're going to end up with 23 minus 4 root 15. Moving on to question 2, this one's a bit more tricky. So there's multiple ways of doing this, but for this specific one, I think the best way is to just rationalize all the denominators and then work with what we've got after that. So with this first one, we know that 2 over root 3 minus 2, we can simplify that and get that into rational territory by multiplying by root 3 plus 2 to the top and bottom. And then with this second one, well, we can just multiply that by root 3 to the top and bottom. So the bottom just now becomes 3. So with this next bit, the first fraction, we're going to get 2 root 3 plus 4 over root 3 squared. So difference of squares on the bottom. So root 3 squared is just 3 minus 2 squared, which is 4. So minus 1. And then plus 2 root 3 on 3. Then what we're going to do is get a common denominator going. So to get a common denominator, we can just multiply this denominator by minus 3 to get it to the same as positive 3. So if I multiply this by minus 3, then I also do that to the top. So I do it to everything on the top. So I end up with minus 6 root 3 minus 12 over minus 3 plus our 2 root 3. Sorry, the denominator is going to be positive 3. Okay, So then we're going to simplify further. Minus 6 root 3 plus 2 root 3, that's going to be 4 root 3, and then minus 12, and then we divide that by 3. Nothing else we can actually do here because the 4 isn't going to simplify much with the 3. So that would be our final answer. With question 7, we've got root 2 plus 1 all to the power of 4. So how on earth do we navigate something like this? Well, simply, we can just think about it like this, right? Root 2 plus 1 all to the power of 4 is just root 2 plus 1 squared times root 2 plus 1 squared, right? Because remember, x to the power of 4, for example, that's just x squared times x squared using our index laws. So we can use that same idea over here. So this first bracket, this first set of brackets, we just use our a plus b all squared, remember? So a plus b all squared is equal to a squared plus b squared plus 2ab. So if we use that, square the root 2, we get 2. Square the 1, we get 1. And then 2ab, so 2 root 2. And then same thing with the second set. It's going to be the exact same. So 2 plus 1 plus 2 root 2. And then we're going to end up with 3 plus 2 root 2 times 3 plus 2 root 2. So if we expand all that out, 3 times 3 is 9, plus 3 times 2 root 2 is 6 root 2. Then we've got 3 times 2 root 2 again, so another 6 root 2. And then we've got 2 root 2 times 2 root 2, which is simply 8. So then we're going to get 9 plus 8, which is 17. And then 6 root 2 plus 6 root 2, which is 12 root 2. So that is our final answer. All right, question 8, rationalize the denominator of this. So how on earth do we go about doing something that has 2 irrational parts on the denominator? It's quite simple. We actually just do it like, we just treat this first thing as a rational part, and then we do it twice over. So that's why this is in brackets. So what we're going to do is multiply by the conjugate. So the conjugate in this case is going to be 1 plus root 2 minus root 5. So we do 1 plus root 2 minus root 5 over 1 plus root 2 plus root 5. And then 1 plus root 2 minus root 5. It might be a good idea to just use these square brackets to differentiate how we're sort of grouping these guys together. Okay. Now, what do we get? Well, on the top is just 1 plus root 2 minus root 5. Forgot that there. And then on the bottom, we're just going to get a difference of squares, right? So it's going to be 1 plus root 2 squared minus root 5 squared. So that's going to be 1 plus root 2 minus root 5 all over. If we square this, we're going to get first thing squared plus the second thing squared plus 2 root 2. Remember, that's just the perfect square formula. And this is going to be minus 5. So then if I keep simplifying, we're going to get 1 plus root 2 minus root 5 all over. 1 plus 2 is 3. 3 minus 5 is minus 2. So we get 2 root 2 minus 2. So what do we end up with? We end up with 1 plus root 2 minus root 5. 2 root 2 minus 2. What are we going to do? We're going to simplify and multiply by the conjugate again. So the conjugate here is going to be 2 root 2 plus 2 and 2 root 2 plus 2. And what do we get? Well, on the bottom, we're going to get a difference of squares. 2 root 2 squared is going to be 8 minus 2 squared, which is 4. On the top, we're going to get 2 root 2 plus 2 plus 2 root 2 times root 2. So that's going to be 2 times 2, which is 4. Then root 2 times 2, so just 2 root 2 again. And then we have that minus root 5, right? So it's going to be minus root 5 times 2 root 2, which is minus 2 root 10. And then plus 2 times minus root 5. So that's going to be 2 root 5. Okay, that's a lot of numbers, but we can finally start simplifying. I might just use a different color to just differentiate the final answer. So 2 root 2 plus 2 root 2, we're going to get 4 root 2. So great, 4 root 2. 2 plus 4 is going to be 6. And then minus 2 root 10, then minus 2 root 5. And then this is all over 4. So we can actually further simplify. So I'll put my final answer up top here. You can see we can make this into a 2, and then make this into a 2, make this into a 3, get rid of that, get rid of that. So our final answer would be 2 root 2 plus 3 minus root 10 minus root 5 all over 2. Okay, so hopefully that makes sense. With question 9, prove that the cube root of 2 is irrational. So for this particular question, what we're going to be using is proof by contradiction. So once again, look at our video on proving why root 2 is irrational for a bit of context. But let's just quickly go through how to do this. And it is quite challenging, and I don't expect most students to understand this straight off the bat. But let's see what we can do. So proof by contradiction means we have to assume something is true and then do all our working. And then if it turns out that we get a contradiction, then our assumption, what we assumed true, was incorrect. So what we're going to do is we're going to assume that the cube root of 2 is rational. Okay? So what happens when we assume that the cube root of 2 is rational? Then the definition of a rational number is that it can be written as a fraction. Okay? It can be written as a fraction as A over B. And this is important, that the highest common factor of A and B has to be 1. Okay? So they cannot have any other factors. So how on earth do we go about doing this? Well, from here, what we're going to be doing is we're going to be cubing both sides. So the cube root of 2 is just 2. The cube of A on B is just going to be A cubed on B cubed. And then from there, we can say, oh, well, A cubed is equal to 2 times B cubed. And therefore, we can say that A cubed is even. Okay? Now, because we know A cubed is even, that means we can say that A is also even, okay? And you can double check this, but if you have any odd number, if you cube that number, you're also going to end up with an odd number, okay? And any even number, when you cube that, it will be an even number. So A is also even. What does that mean? Well, it means A can be written as 2 times another number, right? So let's say that A is equal to 2 times K, okay? So A is even, that's important. Now, if A is equal to 2K, let's go back and do this whole step again. From here, we can say, oh, it's not A cubed anymore. It's 2K cubed, okay? So all I've done is I've just said, oh, well, A is 2K because it's even. And remember, even numbers can be written as 2 times a number. It's probably important to say that K is an integer. So 2K cubed is going to give us 8K cubed, and 2B cubed just stays like that. That means we have B cubed is equal to 4 times K cubed. And if you look at that, well, 4 times anything, K cubed is obviously an integer. So that means B cubed must also be, is also even, okay? So if B cubed is also even, what does that mean? Similarly, we can say that B is also even. So B is also even. And that is where our contradiction is. Because if we have 2 even numbers on a fraction, then both of those numbers can be divided by 2. And that means the highest common factor is not actually 1. The highest common factor is actually 2. So therefore, we say, therefore the HCF, the highest common factor of A and B, is equal to 2, or we can say at least equal to 2. And therefore, we have a contradiction. And what does that mean? It means our assumption that cube root 2 is irrational It is rational is incorrect. And therefore, we can say that cube root 2 is irrational. So hopefully that makes sense. Okay, now we've got question 10. A ravenous motorist departs from the town Bendover, which is 8 kilometers due south from another town, Asman, and drives due east towards a town called Chukok, which is 20 kilometers from Bendover. After driving a distance of X kilometers, he notices that he is in the same distance away from both towns, Asman and Chukok. So question one, and I think that's quite an important question here, draw a clear diagram with all the given information. So we've got town Bendover, so I'll call that B. It is 8 kilometers south of another town called Asman. So we'll call Asman over here. And we can say that this is 8 kilometers. What else do we know? Well, the motorist starts from Bendover and drives east towards Chukok. So Chukok is east, and it is 20 kilometers from Bendover. So 20 kilometers. Now, after driving a distance of X, so our motorist has driven a distance of X, he notices that he is the same distance from both towns, Asman and Chukok. Okay, so what's the distance from where he is to Chukok? Well, that would just simply be 20 minus X, right? Because you can see the whole thing is 20. And if he's driven X, well, then the leftover must be 20 minus X. And the distance to Asman is going to be this distance. And here, what can we do? We can use Pythagoras' theorem because this is 90 degrees. Remember, this is east and that is south. Express the motorist's distance from Asman in terms of X. Well, we were just about to do that by using Pythagoras. So we can say that the distance is equal to the square root of 8 squared plus X squared, right? Remember, watch our Pythagoras videos if this doesn't make sense. And then this is just simply equal to root 64 plus X squared. Now, express the motorist distance from Chukok in terms of X. Well, we've just done that. We've identified that that is simply 20 minus X. And then question 4 is find X. Well, here what we're realizing is that we have to let them equal each other. So we have to say that root 64 plus X squared is equal to 20 minus X. So if we square both sides, that's how we're going to solve for X, right? We're going to get 64 plus X squared is equal to, if I square this, remember I have to square the whole thing. So then that's going to be, square the first term, so that's 400. Square the second term, so that's going to be plus X squared. And then square the third term, so it's going to be minus, sorry, not square the third term, minus 2ab. So minus 2 times 20 times X. So if I just write everything a bit more clearly over here, we get 64 plus X squared is equal to 400 plus X squared minus 40X. Now, what do we do from here? Well, we cancel out the X squared and cancel out the X squared. We move the 400 to the other side. So 64 minus 400 is equal to minus 40X. 64 minus 400, that's going to be equal to negative 336. That's equal to negative 40X. So X is equal to negative 336 over negative 40. And our final answer would become equal to 8.4. So X is equal to 8.4 kilometers, or just 8.4, I guess. So hopefully question 10 makes sense. And finally, the last question of the homework, find the exact value of the following. So this is quite a difficult question, and the way to go about this is to actually just rationalize each single fraction and then realize that there's a pattern going on. So let's first start with this one. If I rationalize the denominator of this first fraction, I'm going to be multiplying by the conjugate to the top and bottom. which is 1 minus root 2. On the bottom, I'm going to get 1 squared minus root 2 squared, right? Because I'm going to be getting difference of squares. So I end up with 1 squared minus 2 squared, which is negative 1. This next fraction, that's going to be, if I multiply by the conjugate of this fraction, it will be root 2 minus root 3. So I'm going to be getting root 2 minus root 3. And the denominator, well, I'm going to be getting root 2 squared minus root 3 squared, which is 2 minus 3, which is also negative 1. So you can see how already I've got common denominators. If I keep going here, I'm going to be ending up with root 3 minus root 4, because that's the conjugate of root 3 plus root 4. And the denominator will also be negative 1. You can figure that out, but it will work. And then if we just write the dot, 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 and go to our last fraction, well, the last fraction is something similar. The conjugate of that is root 99 minus root 100. And then the denominator is going to be root 99 squared minus root 100 squared, which is 99 minus 100, which is also negative 1. So these all have the same denominator. So we just need to look at the numerators now. I'm going to bring out a fancy blue color here, and we can see a couple of things happening already. We've got a minus root 2 plus a root 2, so they cancel out. Remember, this is all on the same denominator. We've got a minus root 3, and that cancels out with a root 3. And hopefully you can see the pattern now. So this would cancel out with this would cancel out with this would cancel out with the next thing in the dot, dot, dot. And all of them are going to be canceling out with each other. And then you realize that the root 99 would cancel out with the minus root 99 before it. So everything apart from this and this has been canceled out. So if we write what we've got left, we've got 1 minus root 100 all over negative 1. Now, if we simplify that, we know that root 100 is 10. So 1 minus 10 over negative 1. We know 1 minus 10 is negative 9. And negative 9 over negative 1 is simply equal to 9. So that is our final answer. And it's quite a simple answer, given the fact that we've got so many fractions and it looks so complicated at the start. But hopefully that made sense. And if you have any questions about the solutions, do chuck them up in the comment section below. Our next topic will be indices, so hope to catch you there.